Okay guys, so for this video we're going to get into 4-4, which deals with geometric transformations with matrices. So we're going to speak about two transformations, or two main types of transformations, which I'm going to get to in a little bit. But first I want to do a quick review of matrix multiplication. So remember, when you multiply matrices, you're multiplying row of the first matrix by column of the second matrix. So let's multiply a 2x3 matrix by a 3x1. So if I have a 2x3 by a 3x1 matrix, I know I can multiply them because these inside numbers here match, meaning the number of columns match the number of rows here, meaning that my final matrix is going to be a, is going to be a 2x1. That's going to be my final matrix. Okay, so let's say I have a 2x3 matrix like this. Let's say I have, let's say 1 2 3 3 2 1, and let's say here we have a 3x1, 3 rows 1 column, and I have 4, let's say 0 1. Okay, well, my 2x1 matrix means I'm only going to have one column. Why do I only have one column? I'm multiplying, there's only 2 rows here by the one column, right? That's what my dimensions mean. So I'm going to have 2 rows and only one column. So I'm going to leave the 2 rows there. Remember, you're multiplying row by column. So the element in row 1, column 1, is going to be the product of the element in row 1 by the only column there is, column 1. So it's going to be 1 times 4, right? 1 times 4 plus the next element, 2 times 0, plus the next element, 3 times 1. Okay, and we're going to do the same thing, but for the next row. So it'll be 3 times 4 plus 2 times 0. Make sure you don't lose track of the numbers, plus 1 times 1. So let's see what we get. We get here, I'm just going to write it underneath. You get 4 plus 0 plus 3. Underneath we're going to get 12 plus 0 plus 1. So our 2x1 matrix ends up being 4 plus 0 plus 3 is 7. 12 plus 0 plus 1 is 13. So the product of these two matrices ends up being this 2x1 matrix over here. Okay, so let's move on to the lesson, which deals with transformations. Today we're only going to discuss two transformations: translations and dilations with matrices. Okay, let's talk about translations first. So a translation is essentially a slide of a figure without change in the size or the shape. So let's say we have the following polygon with these following vertices. Okay, so let's say we have a trapezoidal figure here. You have a quadrilateral. Well, you can write vertices of a figure as a matrix, which means I can write all of these vertices in matrix form. A 2x4 matrix. The 2 rows represent the x coordinates and the y coordinates, and the different columns would represent the points. So here, this A point here has x coordinate of 0, y coordinate of 0. My B has an x coordinate of -1, a y coordinate of 4. C has an x coordinate of -4, a y coordinate of 2, and D has an x coordinate also of -4 and a y coordinate of 0. So this here would be my matrix of the vertices. Okay, it is 2 rows because I have the 2 coordinates, and the columns depend on how many vertices you have. We have a quadrilateral, so we have the 4 vertices. Let me label this point A, B, C, and D. Okay, so when we do a translation, as I have here, it's a slide of a figure without changing the size or the shape. So all you're doing is dragging the same figure somewhere else on the coordinate plane. That's a translation. Okay, And what we're going to have is what we have here is our pre-image, meaning your original image. And when I translate this, or whatever the transformation is, my new figure ends up being my image. Okay, so it's just some terminology. And how exactly do we do translations with matrices? Well, they're done through matrix addition. Okay, because let's do this example to show you how. In example 1, when you're translating a figure, you're saying you have quadrilateral A, B, C, D, the one that I had earlier. I have it down here. I'll refer to it later. With the following coordinates. So let me redo my matrix of the vertices. So we're just going to put the x and the y coordinates, row 1 being the x, row 2 being the y. So I'm going to have 0, 0 for for A, then B is -1, 4. We're going to have -4, 2 for C, and then D is -4, 0. Exactly what we had before. Okay? And we want to translate a figure. Find coordinates of translation 6 units to the right and 2 units down. Well, this is done through matrix addition. How so? Well, a translation to the right or left, we know, is determined by the x coordinates. The x is what determines my left and my right translation. My up or down is determined by my y coordinate. Okay? If I'm moving, try to visualize this. If I'm moving 6 units to the right, my x values are basically going up, because in my coordinate plane, when I go to the right, I'm moving, I'm increasing my x value, which means that I'm going to be adding by each of these x coordinates. I'll be adding 6 because I'm moving 6 units to the right. So it's going to be 6, 6, 6, 6. Okay? And what about my y coordinates? Well, I'm moving 2 units down. I know that's going to decrease my y value. So I'm going to add -2, which is the same thing as subtracting 2. Okay? So when I do this matrix addition, I'm going to get a matrix that represents the vertices of my image, meaning my figure after the transformation. So we're going to have 0 plus 6 is 6, -1 plus 6 is 5, -4 plus 6 is 2, -4 plus 6 is 2. And then underneath we're going to have -2, 2, 0, -2. So these are my image vertices.